Alrighty, so we've done a whole lot of stuff with polynomials, and we've kind of exhausted that process. So we're through with polynomials for right now, and we are going to start talking about rationals. So we are going to review some things that we have to do with rationals before we actually start graphing them and doing other things. So remember that a rational number, is a number that can be expressed as a fraction. So 0.75 is a rational number because it can be represented as 3/4. 5 is a rational number because it can be represented as 5/1. Square root of 2, not a rational number because I get a decimal that I can't make into a fraction, okay? So basically when you think of rationals, what should come to your head is fractions. Like if I can make it into a fraction, we're good. So rational expressions and rational equations are equations that have y's in the denominator that can actually make into a fraction. So we're going to start by simplifying number 1. On number 1, to simplify it, can I reduce this 4 with this 2 right here? No. It's a big fat no. Slap your hand if you said yes. No, okay, because we have addition and subtraction up there, okay? It has to be I know. That's why I always ask you that, because that's a common thing to happen, and when you're not paying attention, you do weird things sometimes. So right now, there's nothing I can reduce as it is. So the first thing I need to do is factor. So I'm going to leave the numerator and the denominator separate for now and work on both of them at the same time. So the numerator, when I factor it, there's no GCF, so I'm going to factor by grouping. So I'm going to do 4 times 9, that's 36. So I'm going to have 4n squared. And then I need 2 numbers that multiply to give me 36, but would add, negatively, add to give me 12. What do you think those numbers are? 6 and 6, good. Minus 6n, plus 9. The denominator, no GCF there either. So I'm going to multiply 2 times 27 is 54. So I need 2 numbers that are going to multiply to give me 54. And since this is negative, they're going to have to subtract to give me 15. 9 and 6. 9 and 6 add to give me 15, but they're going to have to subtract, right? So what normally happens in situations like this, like if I was to give you a minute and I look out there, most people are like staring at the numbers because you're thinking, like you're trying to come up with them. It helps you so much more when you actually write them down. Like even if you can't come up with 9 times 6, you know that 2 times 27 is 54, right? So 2 of the factors, 2 and 27, I'm going to write them down. So then let's say I have no clue what to do next. Well, if I divide 27 by 3, that leaves me with 9. And if I take that 3 and multiply it by 2, I get 6. That's where I come up with 6 and 9. They do add to give me 15, but they have to subtract to give me 15. So now I'll divide the 9 by 3. I'm left with 3. Take the 3 times 6 and get 18. Without doing something like that, most of you probably, it would take you a while to come up with that 18 times 3 because that's not the first thing that pops in your head for that. But you take those numbers and you just kind of manipulate them and make sure they multiply back. Well, these 2 numbers subtract to give me 15. Is 18 minus 3 15? Yes. So that's going to be plus 18n minus 3n minus 27. So I'm going to factor both of these by grouping, just leaving them separate, but keeping them in my fraction here. So these 2 terms, I'm going to factor out a 2n. That leaves me with n minus 3. These 2, I'm going to factor out a negative 3. That leaves me with, that leaves me, what did I do? Oh, I left off my 2 there. Dang it. All right. There we go. Okay, when I factor out a 2n here, that leaves me with 2n minus 3. There we go. And then I factor out a negative 3 here, leaves me with 2n minus 3. Okay, there we go. Down here, these 2, I'm going to factor out a 2n. That leaves me with n plus 9. Here I factor out a negative 3, leaves me with n plus 9. Okay, so now I'm going to pause here for just a minute because there's something that I've seen from people that are doing grouping, and I think most of you are, and there's probably way more of you doing this than I know because I've seen some people doing this, and this is bad. If I was factoring, let's say we just have the denominator, like that's the only problem that we have, like we're just supposed to find our zeros here or whatever. If I stop here, this is not factored. It's in the middle of being factored. Could I figure my zeros out from here? Yes, but I have not finished factoring. And if you get in the habit of stopping and not doing that, then you're going to do weird stuff when you can't be doing weird stuff. So to actually finish the factoring process here, I have 2n minus 3 times 2n minus 3 over 2n minus 3 times n plus 9. Now, the numerator and denominator are completely factored. Like I actually finished that up. So make sure you're finishing that because I can't see your work all the time. Okay, so now that I've factored them both, now can I reduce something? Yes, because now I have these two being factored and these two being factored, so, I'm sorry, being multiplied. So then I can cancel those out. I'm left with 2n minus 3 over n plus 9. Can I cancel my n's out? No, big fat no. That is my answer. What questions do we have so far? You have to be able to factor efficiently and accurately, and you have to know your fraction rules. That's what it comes down to. All right, so let's look at what happens when we multiply and divide. When I am multiplying and dividing fractions, do I have to have a common denominator? No, I do not. I just multiply straight across. Right now, I really don't want to multiply straight across because it looks really yucky. So instead, I am going to start by factoring. I'm going to leave my two fractions separate. In the numerator right here, can I factor this? What is this situation called? Difference of squares, yes. So I'm going to have 7 plus y times 7 minus y. In the denominator, can I factor out a GCF? What would my GCF be? 6y, good. So that's going to leave me with y plus 7. Okay, then I'm going to multiply by this fraction. Can't really factor anything in the numerator, so it's just 48y cubed. The denominator, I should be able to factor into two binomials. So this is going to be y and y. Have to be the same sign, so both negative. Two numbers that multiply to give me 21 and combine to give me 10. 7 and 3, good. Okay, so I still not really excited about multiplying straight across yet. I can reduce, because even if I did multiply straight across, technically I can just make that into one big fraction now and say everything's multiplied together, so I can reduce some things. This 7 plus y, is 7 plus y the same thing as y plus 7? Yes, so I can cancel those out. Is 7 minus y the same thing as y minus 7? No. Because think about it this way. If y is 10, 7 minus 10 is negative 3, 10 minus 7 is 3. So they're not the same thing, so I'm going to leave them there for just a minute. Then I'm going to see what else I can reduce here. This 6, I can make that 1 and it goes into 48 8 times. And then this y can reduce with these and make that y squared. So let me, because I have a lot of stuff marked out now, let me rewrite what we have. I have 7 minus y, and then that's going to be times 8y squared. In the denominator, that first fraction, I got nothing. It's all just 1 now. The second one gives me y minus 7 times y minus 3. Okay. So 7 minus y and y minus 7 are not the same thing. However, is there something I can do that is mathematically legal that would make them look the same? I can change the signs. So how do I do that legally without just willy-nilly changing signs? What could I do to it that would make my signs change? Exactly, I could factor out a negative 1. So in the numerator, if I factor out a negative 1, that means this becomes minus 7 and plus y, so this would be y minus 7 times 8y squared over y minus 7 times y minus 3. Now I can simplify. You can cancel those out. That leaves me in the numerator with negative 8y squared over y minus 3. Can I reduce my y's? No. Slap your hand again. Did you say yes? No, because there's two terms down here, right? I'd have to factorize. Oh, okay. Yeah, that's just y minus 3. There we go. All right, everybody okay with that? Any questions at this point? Okay. Now, keeping up with your work on these is super important. Having organized work is super important. Now, if you have bad handwriting, you're probably at the age where, you know what, nobody's fixing that. You're always going to have bad handwriting. It is what it is. But even with bad handwriting, you can keep your work organized so you yourself can follow it and somebody else can follow it. I mean, that's the most important thing, that somebody can follow your logic and give you points for things. All right, let's look at number 3. So on number 3, we're dividing. And I have a fraction and something that's not a fraction, but it can be represented as a fraction because I can put it over 1. My rule for dividing fractions is that I multiply by what? The reciprocal, exact. Of the second one, not the first one. I've seen people try and flip them both, and that's a big no also. So when I rewrite the first fraction, I'm going to go ahead, I can factor some things out. So I can factor out a 30c squared. That's going to leave me with c minus 2 over 3c. Then I'm going to multiply by the reciprocal of this, which is 1 over. And then on this one, do I have a GCF I can factor out here? 2c, actually, right? So then that's going to leave me with c squared minus 8c plus 12. Okay. So I can factor that denominator over there on the second one even more. So when I rewrite this, I'm going to go ahead and reduce some of this. So the 3 can go into 30 10 times, and this c can cancel out the squared there. So then that leaves me with 10c times c minus 2 over 1 now, times 1 over 2c, and then I'm going to factor that trinomial. This will be c and c. The signs have to be the same in both negative. What are my numbers? 6 and 2. Good. 6 and 2. So now that I have everything fully factored like that, I can reduce this. This c cancels out with this one, and the 2 goes with the 10 and leaves me with a 5. And when you're canceling out and stuff, make sure that you can still see what's actually there. Because sometimes, and that's why when you're doing your work digitally, you're at an advantage where you can use different colors like I do. One of the reasons I do that is so that when you're looking down and you look back up, it's kind of easier for you to catch what I did. And it's also easier to tell, like, everything's canceled out except the 5, and then you can also see what's left here. So just be careful so you don't lose anything. So I have 5 in the numerator. This 1 times all I have left is 6, and that's the best I can do. That's my answer. Any questions at all? Okay, so we multiplied and divided. Let's talk about adding and subtracting. When I add and subtract fractions, what do I have to have? Common denominator. This one, I have 1. That's awesome. So I know what my denominator is. It's going to be m squared minus 25. So then in the numerator, I'm just going to go ahead and subtract. So 9m minus m is 8m. And then what's going to come after my 8m? Is it a positive 16? No, why not? When I'm subtracting everything. Even though there's not parentheses there, I'm actually subtracting all of that. So not only do I have to subtract this m, but then it's negative 12 minus 28, so I get a negative 40. So be careful with that. Those are the kind of things that throw you off, and then once that sign is wrong, everything else is just wrong. So the parentheses don't have to be there, but it's not a bad idea for you to put them there yourself. So hopefully you will handle that correctly. Definitely a common mistake. All right, so in the numerator, I can factor out a GCF. It's going to leave me with m minus 5. Can I factor the denominator? Yes, because it's a what? Difference of squares, yes. So m plus 5 times m minus 5. Those cancel out, and I'm left with 8 over m plus 5. Any questions at all? Alrighty. Let's look at 5. So on 5, we're subtracting. So I need, again, a common denominator. When I don't have a common denominator, one of the quickest ways, I wouldn't say easiest, but the quickest ways to get a common denominator is just to multiply the two denominators together. I would really like to avoid doing that on number 5 if possible. May not be possible, but maybe it is. So before we start trying to combine these fractions, why don't we factor and see if we can do anything before that that might help us out. So for this first fraction, I'm going to try and factor this first equation here. So that means I need two numbers that multiply to give me 51 that would subtract to give me 2. So is 51 a prime number? No. And here's why you should know that it's no like that without having to try and guess and check at all. If you don't know the trick for knowing if a number is divisible by 3, you need to listen up, okay? Because if you want to know if a number is divisible by 3, you add the digits, and if the digit and whatever you get is divisible by 3, then the number is. So 5 plus 1 is 6. So I know it's divisible by 3. Even if you don't know what the answer is, you know it's not a prime number. So think about 122. Is that divisible by 3? No. You know why? Because 1 plus 2 is 5. So it's not divisible by 3. Is 123 divisible by 3? Yes, because 1 plus 2 plus 3 is 6. You know, and then from there you can figure out what the number is, but that's how you know if a number is divisible by 3. That trick really helps you when you're simplifying square roots for sure. So I know it's not a prime number. So if I divide 3 into 51, I get 3 and 17. Well, those are not going to subtract or add to give me 2, so that doesn't help me. And since these are both prime numbers, those are my only options besides 1 and 51, which means the numerator I can't factor. So I'm just going to rewrite it. P squared plus 2p minus 51. So let's see if we can factor the denominator. I'm going to need two numbers that multiply to give me 27 that subtract to give me 6. Am I going to be able to do that? Yes or no? Yes. So I can factor this one. I'm going to have p and p. This is negative, so the signs have to be opposite. Then the two numbers are going to be what? What? Negative 9 and 3. Good. And we should know that 3 times 9 is 27. But if we didn't, 2 plus 7 is 9, so I know it has to be divisible by 3. Okay, so that doesn't necessarily help me just yet, but I'm going to rewrite. I can't do anything to the second one. Let me just rewrite it. And then I got p plus 3. Okay, so since I have this, can I find a better common denominator than just multiplying these two things together? Yes, because that first fraction, the denominator is p plus 3 times p minus 9. I have p plus 3 right here. So if I just multiply it by p minus 9, then I have then it's the same, so that means I have to multiply the numerator by p minus 9 as well. So if I rewrite all that, I'm going to get p squared plus 2p minus 51, and then I'm going to just go ahead and do this. Negative 4 times p is negative 4p, and then negative 4 times negative 9 is a positive 36, and all of that is over p plus 3 times p minus 9. Everybody good so far? So now I'm just going to combine my like terms in the numerator. So p squared minus 2, minus 2p minus 15 over p plus 3 times p minus 9. So now that that numerator function has gotten some other things added and subtracted into it, maybe I can factor it now. So I'm going to need two numbers that are going to multiply to give me 15, and combine and subtract to give me 2. Am I going to be able to come up with those? Yes. So my denominator is still p plus 3 times p minus 9. The numerator, p and p, so there'll be positive and negative. What are my two numbers? 3 and 5, and the 5 would have to be negative. So now that I have all that done, I can reduce this, and then I get p minus 5 over p minus 9. Diego, can I cancel the p's out? No. Okay, good. Then I'd have slapped your hand. No, I'm just kidding. And I know sometimes when y'all answer yes or no quickly, like you hadn't really thought about it yet, but I just want to make sure that we don't start doing weird things, so you want to always ask yourself that. All right, are we good? Okay. Number 6. So here I want to add these. I need a common denominator. This is going to be a little bit more straightforward, right? So my common denominator, I can just multiply these together. So I'm going to say, all right, well, my denominator is going to be h minus 2 times h minus 5, which means this fraction had to get multiplied by h minus 5 over h minus 5. So that means I'm going to have 3 times h minus 5. Plus, this one had to be multiplied by h minus 2 over h minus 2. So this gives me 5 times h minus 2. Can I cancel out these h minus 2's? No. Because first of all, I just put it there so I could combine them, and I can't do that because there's addition right here. All right, so I'm going to distribute in the numerator. I'm going to get 3h minus 15 plus 5h minus 10 over h minus 2 times h minus 5. Then in the numerator, I'm going to just combine my like terms. This gives me 8h minus 25. Can I factor out a GCF in the numerator? The only thing 25 is divisible by, besides 25 and 1, is 5, and so no, there's nothing I can factor out in the numerator there. So can I reduce this fraction at all? I can't. And sometimes we can't. Like we added them and we simplified, but we can't reduce, and sometimes you can't. Just like if I gave you 3/4 and I said reduce that fraction, okay? It's 3/4. I can't do any better than that. Any questions at all at this point? Okie dokie. Then let's look at number 7. So we got complex fractions, and we've already dealt with these a little bit, but this really isn't any different than number 3. Number 3 was written as division. This is division. It's the numerator divided by the denominator. So when we do this, you just multiply by the reciprocal of the denominator. So this is going to give me 15x minus 10 over x minus 8 times, then I have to make sure I take the reciprocal of this, x squared minus 12x plus 32 over 3x minus 2. So now that I have it set up as multiplication, I'm going to go ahead and factor what I can factor. So that means in the first one, I can factor out a 5. That leaves me with 3x minus 2 over x minus 8 times, then this denominator is 3x minus 2. Now, even if you already notice, oh, hey, I'm going to be able to cancel those out, don't do it yet. If you start canceling before you write everything down, sometimes that leads to you forgetting to do some things. So let's just get it all in there, and then we'll simplify. So this one I'm going to factor. It's going to be x and x. This is positive, this is negative, so the signs are the same, both negative. Two numbers that multiply to give me 32 and combine to give me 12. What are they? 8 and 4, good. So we get 8 and 4. So now I have everything as factored as I can get it right now. See what I can reduce. Well, this 3x minus 2 cancels with this. This x minus 8 cancels with this. So then I am left with 5 times x minus 4. And that's it. not over 1. Technically, over 1 is not wrong. However, we wouldn't write it that way. It doesn't have to remain a fraction. It's still rational because I can write it as a fraction, but okay. What questions do we have? All right. Again, it's all about factoring and fraction rules. Lots of places to make careless mistakes, especially if you're sloppy or try to skip a bunch of steps. So just be careful with it. Alrighty, let's look at number 8. So on number 8, I have a fraction and a fraction again, but instead of having, sorry, ugh, my board. Hang on. Okay, there we go. Instead of having one fraction over one fraction, these are, I have 2 fractions in the numerator and denominator. So before I start multiplying by the reciprocal and getting it out of a complex fraction, I need to make this into one fraction here and one fraction here. So I have to leave it as a hot mess for a little bit. And I'm going to work with the numerator first. So I need a common denominator for the numerator. And the common denominator for the numerator would be what? V squared. Very good. So if it's v squared, that means this fraction gets multiplied by v over v. So that would be 4v squared, and then minus, this one's fine, so this is minus 1. So that's the fraction in the numerator. Everybody okay with where everything came from? All right, so then the common denominator of the denominator is going to be what? 2v. Very good. So that means this has to be multiplied by 2v over 2v. So this will give me 2v minus 1. Any questions about where anything came from? Okay, so now that I have a one fraction over one fraction, now I can change this to multiplication. This can become 4v squared minus 1 over v squared times, and make sure you take the reciprocal, 2v over 2v minus 1. So I can reduce a little bit right here. I can cancel this v with one of those. It's really all I can do at this point. But this right here, this numerator, can I factor that, the 4v squared minus 1? Yes, because it's a what? Difference of squares, yes. So this can become 2v plus 1 times 2v minus 1, and then I still have this times 2 right here, over v times 2v minus 1. So now that I have that all put together like that, now I can reduce this with this. And then that's going to leave me with 2 times 2v plus 1 over v. Can I cancel my v's out? You unsure? Nobody's answering, so I don't know if you're unsure or what. I cannot, because there's addition right here. Like if it was just a v out here, I could, but no, it's not going to just make that 3 inside of there or something, so I can't. And here we go. That's it. Best I can do. Okay. What questions do you have? Anything at all? So that's a big fat review, has a lot of factoring in it, a lot of fraction rules, but you got to be comfortable with that, efficient and accurate with factoring and with fractions to be able to get through the other stuff, okay? Any questions at all? Alrighty. If you are a junior, next Wednesday, you are taking the PSAT. If you're a sophomore, then you're taking it on another day later. Don't remember what the date is off the top of my head. And if you're a senior, then you're going to be taking the SAT in a couple weeks, but I don't remember that date either, but I'll let you know. But if you are taking the PSAT next week, then one thing you can do before that, because it's a reasoning test, it's not a content test. Now, having content under your belt helps because you've gone through some of the skills. But in the end, it's really a reasoning test. If you want to brush up on some things and see some problems like what you would expect, if you go to satpractice.org, then that's the easiest way to get to the PSAT and SAT practice that's in Khan Academy that's tailored to you. You can get to other Khan Academy SAT stuff a different way, but if you go straight to Khan Academy and try to get where this actually takes you, it's complicated. I don't know why. But if you go here and it asks you to log in like you would for Khan Academy, and then if you already have your account tied to College Board, which I'm hoping you do, but if you have your account tied to College Board, then all of your former scores should already be in there, whether you've taken the PSAT or the SAT, and then the practice that you do is tailored to you, what you actually missed, what you can and if it's not in there and you can't get it in there, then you take a little diagnostic, then it knows what kinds of questions to give you instead of just everybody getting the same thing. If you want to get it tied to College Board and you can't figure out how to do that, let me know and I can help you with it. But if when you do that, you have to know your login for College Board. So I can't help you if you don't know that. And if you have multiple College Board accounts, that's a problem too. If that's the case, then you need to call College Board. And there's going to be a number on their website somewhere, and you just tell them, I don't know why, but I have 2 accounts. And they're very good at helping you and helping you get them combined. Okay? Any questions about any of that? All right.